Assalamualaikum everyone, I'm Muhammad Khairul bin Abdullah with matric number 73573. I'm from PKE2. Alright, first of all, this is the circuit that we'll be using in this project. There is 1.5 volt batteries connected with R1, R2 and R3. R2 and R3 are in parallel, R1 are in series. So the first step, we will simplify the circuit to calculate the theoretical value. So here's the first step. We can see that R2 and R3 can be simplified using the formula of parallel resistor. Next, all of the resistors are in series, then we can combine to get the R total. Alright, this is the simplified circuit, so we can find the I total, which is the current. We will divide the voltage with the total resistance, so we can get 1 milliampere. The I total in this circuit will equal to I1 and and I23, which is 1 milliamp. So from there we can find V23, which is V23 is equals to V2 and equal to V3, which is 0.5 volt. After we get the voltage, so we can find the I2 and I3. I2 is equals 0.5 milliampere and I3 is equal to 0.5 milliampere. So we can put the value into the table of theoretical and measured value to differentiate the theoretical and measured value. So now we will start with the measurement. So now here is our multimeter and it is functioning, and here's our 1.5 volt batteries and our breadboard with connectors and our 3 resistor, our 1 kilo ohm resistor. So for the first step, we will measure each of the resistor to ensure the resistor is 1 kilo ohm. So we will set the multimeter into 2 kilo ohm. We'll start count. So the first resistor, oh sorry, here is the first resistor. So as you can see, the value is not very constant. Okay, right, the first resistor is 0.987. right, we can take a note that R1 is equal to 0.987. Alright, so next we will count for R2. So here is the R1, next for R2 and R3. For the R2, we'll count again. What is the, oh sorry, here is it. See, there's the value for R2. We're still not having a constant value. Alright, it is 0.985 for R2. 0.985 for R2. Right, we put it here for the R2. And the last one for R3. For resistor, the value is 0.988. Okay, it's near, so all of our resistor is near to 1 kilo ohms. So it is now, the value is 0.988 kilo ohm. So next we put the resistor on the breadboard to ensure the arrangement is the same as the schematic diagram. just now. So here is R1, R2 and R3. We can see R1, R2 and R3 are in parallel, and R1 is in series, and we will connect it with the battery. So now we will connect the battery to the breadboard. So here we have connected. So now we will start our measurement. So first we will measure the voltage across all of the resistor, and here is the table to differentiate the theoretical value and the measured value. Theoretical value is calculated as shown before this. So we will measure the voltage for the measured value. First we will measure the voltage across R1. So now this is, we want to measure the voltage across R1. So we can take note that the voltage is 0.928. So now we will take measure. We will measure for R2, voltage across R2. Alright, we will calculate the voltage across R2. And it shows okay, wait. It is 0.6. Wait for a while, and it is 0.462. Right, we take a note. It is 0.462 for voltage across R2. And we off the multimeter and take a measured value for R3 across R3. So now we will measure the voltage across R3. So the voltage across R3 is 0.6. Oh wait, we will wait for a while for a constant value. I think it is 0.64. Right, it is 0.64 for voltage across R3. So now we will calculate the total voltage across this circuit. Alright, this is the total voltage across the circuit. Alright, so you can see the total voltage is 1.399. This is for the total voltage. Alright, so next we will calculate each of the current flow through each of the resistor. So the first one is through R1. You see the current through R1. So the current through R1 is, we can see that it is 1.62. Right, you can see clearly 1.62. 1.261. Alright, sorry. So now we will calculate for the current across R2. Alright, so now measure the current across R2. So it is 1.36 milliampere. Right, so we'll move for the current across R3. So okay, this is the current across R3. Alright, so it is 1.34. So now we will calculate the total current across the circuit. Put it here to calculate the total current across the circuit. There's some problem with the connector. Right, we will see the current across the circuit. So I think it is 1 milliampere. Right, for the total current across the circuit. Alright, that's it. We will see the table of comparison between the theoretical and measured value. So here's the comparison table between theoretical value and measured value. So as we can see, for the voltage, for the partial voltage, there's a slightly different between the partial voltage for R1, R2 and R3, but there is a large gap between the partial current of R2 and R3. So we consider this there's an error occur during the measurement, and it is maybe human error and instrument error. So as we can see, total voltage are a bit different, and the current are the same, the total current are the same. Right, thank you.